Good evening, folks. Welcome to YouTube Model Builders Hangout. Tonight we are having Barry and Mike's new Model Railroad Tech Show. It's me, myself, and I, along with Mr. Mike Dettinger. Tonight we'll be discussing DCC decoders, installations, etc., different wiring techniques. So I hope you guys have lots of questions lined up for us. And let's do a little work here for our show. Okay. So, YouTube Model Builders. Everybody knows who we are, and we've been doing this for almost a year now. We have our free online e-mag, which in the next couple weeks, it should be coming out with the 3rd edition. And like tonight, we're doing our live chats and presentations on Tuesday nights and Thursday nights. And so come join us every month on the live show. And make sure you check on YouTubeModelBuilders.com for all our schedules and event postings. See what's coming up in your neck of the woods. So tonight, like I said, we're doing decoder discussions. So first thing I want to start with here is a basic layout of what a decoder really is on the inside. As we all know, DCC is actually a square wave AC signal. It's not a DC voltage. It's just a very high-speed switched AC signal. So the signal comes in off the rails, and the first thing it does is goes to a bridge rectifier, which you'll see here. The bridge rectifier is actually what converts the square wave AC into a DC to power all the electronics. So from there we have the actual processor, which is the brains of your decoder, and that talks to the motor control system, which has all your back EMF, etc. And then your function processor here, which controls all your function outputs. And what we have here is a simple 4-function decoder. So we have our white and yellow wires, our functions 1 and 2 for forward and reverse lights. And we have the green and purple wires, which are functions 3 and 4. We have our blue wire, which is our positive voltage common. Always remember that when you're wiring LEDs. The blue wire is typically plus 12 volts, unless you have resistors in the decoder already. They should usually tell you if there are built-in resistors for low voltage bulbs or LEDs. Then we have our orange and gray wires, which go to our motor, and then finally we have the red wire, which goes to the right-hand or engineer side of the locomotive, and the black wire goes to the left-hand rail.
Yeah, and Barry, I think it's important to point out that the black and red wire just have to go to the track. It really doesn't really matter in terms of how they get wired. And also the orange and gray wires go to the motor. And it's not really necessary to figure out the positive side of the motor per se, simply because you have CV29 where you can change the direction the locomotive travels. So it's not imperative that you remember that rule, although it's a good practice.
Yeah, because that way you don't have to do any magic, and you reset your decoder. Why is it going backwards? Oh yeah, I miswired it, Yeah.
I got a question. I got a quick question. I don't want to interrupt you, Barry, but
that's all right.
Is it normally the bottom of the motor, the bottom wire, and the top wire? The bottom wire would be positive or negative, and the top wire would be positive. I mean, just rule of thumb. Would that way it would normally be?
I believe so, dude, yeah. Because most of the time, especially on older locomotives, the bottom terminal of the motor went to the frame, which is typically your left-hand rail, which would, in this case, would be your black wire or the, quote, negative wire. Because once the DCC signal comes to the bridge rectifier here, you now have a positive, which is your blue side, and the black wire here, which is your negative side. So that's feeding into the motor processor here. So there is a positive and negative voltage coming through the motor. If you reverse the wires, like Mike said, the motor just runs in the opposite direction. Same if you reverse the rails, it'll make it go in the opposite direction. You just adjust it with CV29 to control your direction of operation. So let's take a quick peek here and see if we have any good questions related to this on the Q&A. Nothing yet on that, so we'll continue on here with our discussion. So the next slide here, this is our standard 8-pin NMRA connector. So as you can see, pin 1 is your orange positive on your motor. Pin 2 is your yellow, or your second light function, which is your backup light. Pin 3 is not used at all. Pin 4 is your left or black track pickup, which is the fireman side. Pin 5 is your gray motor negative connection. Pin 6 is your white lead, which is your headlight. Pin 7 is your blue positive voltage function connection, which all the lights and such in the locomotive connect to. And pin 8 finally is the red or right-hand engineer side track pickup wire. This has been cast in stone since day one when DCC was first, proposed the NMRA as a standard. So any locomotive with an 8-pin harness in it, and an 8-pin connector, can be wired up using this color code.
Right. Now the thing is to look at this connector too, it's symmetrical. If you've been paying attention so far, you'll realize that if you took this connector and did a 180-degree turn on it, it would still work, although the locomotive would go in the opposite direction.
And the lights will be backwards too.
That would be correct. Originally too, the pin 3 was used for the green wire, and what happened was that people, when they put the pin in backwards, they would blow up the decoder, and that's why pin 3 is no longer used.
Okay, so basically what you're saying, Mike and Barry, is because Chris Healy did a hangout last night, and he had it plugged in one way, it didn't work. He turned it around, and then it worked. But now, if you plug it either direction, you plug that in, it'll work. It may go reverse would be forward, vice versa if you turned it around, right?
Well, yeah, that's correct. If you put it in the wrong way, the quote-unquote wrong way, you will get the motor function to work, but not a light. And if you flip it the correct way, you will get the lights to work.
Yeah, if you notice, if you flip this connector 180 like this, now your black would be here, and the red will be there, the gray will be here, and your orange will be there. And then conversely, your lights would flip as well. So it really won't hurt anything, just that it reverses everything. And that's good to know, because it's really almost foolproof. If it doesn't work, you just, the way you want it, just plug it in the other direction. As there are some installs where, like Proto 2000 locomotives, some of them are very tight fit, and you actually have to reverse the connector because it's the connector on their factory board is oriented the wrong direction. So you have to take their board off, reverse it, and then be able to plug it in. So usually most of the online installation sites give you that kind of information, though.
So basically what you're saying is when the black and if you turn the connector around, the black and red are vice versa to each other no matter what.
Right, because when you turn it around, it's not like you're mirroring it in this direction. You actually rotate it 180. So this is going to rotate around to this position. This is going to rotate around to that position. So it's really just reversing the wires, which is reversing the polarity. And because of the bridge rectifier thing, it won't hurt it. It just reverses the direction of operation on the motor because the two motor leads here get electrically reversed. The track pickup won't have as much of an effect on it as these two will. Now, what's becoming a little bit more common in more modern locomotives, and especially in Europe, is the MTC 21 pin connector. the advantage of this, if you'll notice with like some decoders, like say a wow sound, where they have 9-pin on one end and a 7-pin on the other end, that has all 6 light functions. That's your speaker, your keep alive, and all that stuff. This here allows you to have all of that in one connector. So it's actually more and more manufacturers are going to this style, just because you plug this in, you put this on your board and you run your wires, and there's nothing for the user. There's no extra wires for the end user to run. Everything you can see here, we got your function 0 white, which is forward, yellow reverse. You have track, you have ground, you have motor, you have your plus, you have all your auxiliary functions, you have your speaker output. There's 4 auxiliary functions here. The VCC is your plus 12 blue line, and I'm not sure what those other 3 pins are there for, nor the TV clock and data, but everything else allows you to have at least 4 functions on here, and these may be the additional 2. I'm not totally positive on that. I'd have to do some more research on that. But
yeah, I mean, basically what's happening here, Barry, too, some of these auxiliary pins can be used for things like servos to do pulse width modulation, control. It's interesting because the aux wires are just extra wires that manufacturers can use for anything. They're kind of like wild cards.
Oh, okay, so you could put your function wires for lights in there if you wish.
Yeah, actually, a lot of it is, a lot of them are dual purpose. They can either be used as a lighting function or like I said, to control a servo. It's really a kind of a just, is there a lot built into that spec?
Yes, absolutely. All right, so let's pop on here. So here's a very versatile thing that everybody that needs to do decoder install should have in their toolbox. This is a standard 8-pin NMRA harness to a JST9 connector, which is very popular on a lot of decoders. So you should always have a few of these stuffed in your toolbox. Makes it real quick and dirty. If your locomotive has an 8-pin connector and you have a, whoever's decoder with a 9-pin, say TCS or whatever, just plug it into here, plug this into the board, you're ready to go. And the other kind you want to keep handy is some of the shorter versions of that same thing, plus the 9-pin bare wire harness for doing hard wire installs. This makes them go so very quick. And there's really no, or very few decoders that have direct 8-pin connections. They almost always go through a JST9 to an 8, because this takes up a little bit less room on the board than all the discrete wires does.
The other benefit of the JST9 connector too, Barry, is that it gives you 2 extra functions.
Yes, you have a total of 4 functions on there compared to the 8.
Right, you got the green and purple wire.
Yep. Alrighty. So, why don't we get us some questions going here? So, our first question here we got is from Randolfo. It says, details impact on lights. Changing over to LEDs and their particulars would be helpful.
I assume that he has light bulbs in place.
That's what it sounds like, yeah. So you're interested in getting some LEDs in, so.
Right. Now, I mean, with light bulbs, there's a lot of considerations there as well, because the characteristics for dimming and such are a little bit different than LEDs, although most decoders can accommodate both. The other thing with LEDs is they can only handle somewhere between 2 and 3 volts. Anything more than that, they'll blow up. So you have to put in a pull-up resistor or buy a decoder with the pull-up resistors already installed.
Yeah, this is true, because it's so much to worry about sometimes, damaging if you're not careful, because unless the decoder specifically says it's designed for LEDs, you should assume that all the function outputs have rough 12 volts on them.
Right. Right. So, I mean, typically with an LED, and we were having this discussion earlier today, Barry, typically what I do, instead of worrying about the math, I just throw in a 1K ohm resistor, 1,000 ohm resistor in series with the LED to handle that extra voltage, to, you know, basically absorb it. Simply put, if you look at an LED spreadsheet, it'll take somewhere between 20 and 30 milliamps. If you do the math for a 1K ohm resistor, you're roughly looking at about 10, maybe 12 milliamps. And the thing is, with LED lighting characteristics, at about 10 milliamps, the thing comes on at 75, 80% brightness, and it only goes up incrementally as you pump more current through it. So in all honesty, the 1K ohm is pretty much a safe value resistor, and it saves you from doing all that math.
Yeah, this is true. That was a great point you had made earlier to me today, and I never really looked at it from that perspective. But 1K is kind of like the de facto standard that people suggest for your lighting functions. And like Mike said, I mean, as long as you have enough current to light the LED, it'll light. I mean, there's not a great range where you can dim it using current control. So as long as you have enough current for it to function, it'll function properly. I hope we answered your question there, Randolfo. All right, so just to let everybody know, we just went out and posted the panel link, and there's a few open spots if anybody wants to jump on board. So, and we'll go through and see if we can grab a few more questions here. Let's see what Mr. William Graham has to say here. How hard is it to install a decoder in an Athearn blue box engine? Is there any special milling to the body you have to do to make the decoder fit? Typically not in an Athearn blue box. Now the more modern blue box engines, yes. Like this one I have on my bench here. This is a Bachmann Spectrum GP30 chassis. I did not have to mill anything because in the blister behind the locomotive, you know, the dynamic brake blister, there was sufficient room for me to just lay my decoder on top here. But sometimes you might have to mill out the back area or something for a speaker, or mill out in the front to fit a decoder. But the old original blue boxes, no, because they're totally open frame. Whereas something like this, to get the weight in there, it's not. Now, Mike, the one you're working on, right there.
Yeah, basically what I have here is Proto 2000 BL2s, and the reason I brought these out here too, and what's kind of good for Bill's question here, is that these are basically clones of the Athearn Blue Box engines. So if we were to pop one of these bad boys open this guy up here. Okay, we'll make sure I stay in frame here. That should come off very easily. Okay. Basically, there's this is the older version too, but you'll see basically they have little metal towers for bring the conductors up. There's a bus bar on the top. The frame completes the circuit. And it's essentially a clone. What we see on this one here, it has a plastic, it doesn't have a real motherboard, it's a plastic board that'll pop off. Let me just, through the magic of television, I think I have one here. Oh, this one here. Here we go. Let me pop this guy open. All right. There we go. Take you out of the way. I have a couple of these guys. All right. So anyway, that board pops right off, and then you can see the bus bar on top. That's pretty much an Athearn. The only real difference.
Move that up a little higher, Mike, because you're out of your camera.
There you go. I missed it. I'm sorry.
There you go. There you go.
There you go. Look at the screen. There you go. All right. So you got the bus bar on top. and that'll pop off. And then you have bars on the motor on the top and bottom. And these bars keep these springs and the brushes in place. Now what you have to do for DCC to make this work, and this is true for Aether and blue boxes as well, is the conductor on the bottom has to be isolated from the frame. You have to put a piece of Kapton tape or something on this bar on the bottom before you put it back in and put it back together. And what you can do as well, just to make assembly easier, you can cut these towers short. You don't need this top bar at all for DCC. You can just cut that off, throw it out, and you can solder a wire between these two towers and into the decoder to make things a lot simpler. Because when you pull the motor out, you try to put it back in and try to line up these gear shafts right under these little gear towers, they're a real pain in the rump. So, you know, cutting these down short, it just makes a nice option. Let me show you on one I have here as well where I did that. I don't know if you can see that as well. I cut the towers down and I soldered this red wire between the two to keep them electrically connected. Okay. So that's going to make the install a lot easier. Now, also I have the motor here where I already took the Kapton tape on the bottom, just taped it off. And at this point, what I can do is I can solder on the lead, the orange and gray wires right here. And I actually redid the, I think you can see that as well. I redid the plastic motherboard, wired in new lighting fixture. I used LEDs. Again, these are my 1K ohm resistors. I use discrete components here. And at this point, what I can do, if I don't drop it, I can cut these down, I can solder this together and get this running within like 5 minutes at this point.
Something to take note of, Mike, is in the original Aether and Blue box, the way the lower motor contacted the frame was it had a triangular tab that actually stuck into the frame metal. So what a lot of people do is very carefully take that tab off and either remove the little triangular tab or else put that on top and bend it down and put the top clip on the bottom of the motor. But you got to be careful because that way you might lose your brush springs and everything that way. So if you can safely clip off that little triangular tab at the bottom on an Aether and Blue box and then put Kapton tape on it, you'd be much safer, you know.
Right, exactly. The Kapton tape is nice. It's very thin, very fine. It's also has a great insulating property as well. So it's definitely the way to go. The other thing I like to do as well when I'm working on an install like this, if I think that this bar is going to touch any part of the frame, I'll take the Kapton tape, and I don't know if you can see it here. But I will.
Yeah, we can see it.
I will put the Kapton tape on the frame just to make sure that it's secure.
Hey, Larry, I have a question for you, brother.
Yes, go right ahead.
Now, in that process, okay, how hard is it to hook up ditch lights when you're at that process as far as you've got your engine, your framing, everything stripped down? How hard is it to run ditch lights to an engine that does not have them?
It's really not that difficult. It depends upon what kind of ditch light housing you have. I mean, there's a lot of ways you could do. You could put, you know, have housings that are drilled out to design to hold a light bulb. You could put like a micro LED in there. You could even run fiber optics to an LED up inside the locomotive. The easiest way I find it would be to get a housing that looks like you want that you can either drill out or has already been drilled out, so that you can put an LED in there. And if it doesn't come with a lens, let's see what I've got here. Pull my camera up here for you. This stuff is the greatest stuff in sliced bread. Aleene's clear tacky gel. It's actually just like tacky glue, but it's totally clear. I use this to fill headlight housings, like on steam engines and diesel engines. You just put a little dab of it in there, put your LED in place, and let it, you know, tape it so it stays still until it dries. Then if you need to add more to fill up the housing, you just do it. And this stuff works great for securing LEDs and stuff like that. So you can put a little dab of this into the opening on a ditch light, insert your LED in, set it aside and let it dry, and then run your wire from your LED up inside, connect it to your function leads and ditch lights.
Oh, cool. Because I've got a GP42 that it does not have ditch lights on it, and I know it probably don't have them in real life, but I like ditch lights. They look good, especially when they're coming at you.
Oh yeah, I can't disagree with you on that, Scott. I mean, they do add a nice feature to the locomotive, and there's some easy ways to do it. I think the hardest is probably fiber optic. You know, I prefer LEDs to something like that because that way they never burn out. But if you should decide I really want bulbs, there's a couple different ways you can do it. You can use resistors just like you would with an LED, or TCS makes a 1.5 volt regulator, a little tiny chip that you can hook onto your function outputs, and then it provides 1.5 volts for micro light bulbs. So that's another thing you could do too, but that adds extra cost and complications. A simple resistor and an LED or a light bulb is probably always going to be your easiest choice.
Okay, now that would be what, about a 1 millimeter LED?
I guess I could use a 1 millimeter. I prefer to use surface mounts myself. I mean, I have something like that. You use like an 0603 surface mount, and you can go to like Evans Lighting, who makes they make all kinds of LEDs, and they sell them, you know, fairly cheap, pre-wired with a resistor in them and everything, and just glue it in place, solder the wires, you're done. You know, me and Mike bought a big cache of them for use in our modeling. You know, we bought like they call what are they, the Pico or the Nanos, Mike, the 0402s?
The 0402s are the Pico, the 0603s are the Nanos. And then they have a bigger size surface mount chip, and that's like the Mini.
Yeah, that's like a 1208, so that's like 0.12 by 0.08 inches.
Yes. So, in the world of surface mount LEDs, it's humongous.
Yeah, this is true. It really is. I mean, they're pretty big. 0603s is a very common size you can use for headlight lighting and stuff. Smaller things like marker lights, maybe ditch lights, an 0402 would be better. And you'd be amazed that little microscopic chip how much light it puts out. Now we have a question here from Almar Jr., my buddy we met up at Amherst. So can't you just use the LED with the bridge rectifier built in? Well, here's the issue that the bridge rectifier just converts the switch to AC on a track to DC, but it passes through almost the full track voltage. Like I said, roughly 12 volts DC after you get through the rectifier. So the problem is the LEDs, like Mike said earlier, take between 2 to 3 volts depending upon the color and type of LED. So you need to drop that voltage, and the bridge rectifier is just that. It rectifies AC to DC. That's all it does. So you can actually go ahead and just put, like Mike said, it's very easy, 1K ohm resistor, 1/4 watt in your LED, and don't use one in the common function lead. Put one for each LED, because if, say you have 4 bulbs and you put one on your common, you might not be dropping the voltage enough now. So you have to make sure that each bulb has its own on the negative lead, on the LED, and the common is straight wired through, no resistors in the common.
Yeah, that's right, Barry. I mean, basically, the bottom line is LEDs are greedy when it comes to voltage, so and current. And if you have only one resistor in the circuit, the current will be the same throughout the whole circuit. And if it's too much current, you'll end up, even if you get 2 LEDs from the same batch, there's enough variation in the LED manufacturer that you will probably fry one of them.
This is true, yeah. All right, we've got another
Besides,
question.
resistors are like a penny a piece, so don't cheap
Yeah.
out.
Yeah, they're still not expensive. Even when you go to Radio Shack, if you can find one and buy them. So Bill here, Bill Graham, our brother Big Bill, says, what tools would you recommend for a beginner to install a decoder? What decoder would you recommend for all-around use? That's a good one. Well, tools, obviously, you need a decent soldering iron, something with a nice, you want like a pencil point.
You really need a fine conical tip.
Yes, exactly, yeah. Something not like a blunt point. You want a very nice, like Mike said, a conical, so it comes with a real fine point. That way you can get in there to solder small, connections and stuff like that. Need, need like wire. You can buy decoder wire anywhere that's actually the right colors. It's Teflon coated. LEDs, with the surface mounts and stuff, you can use magnet wire, which is enamel insulated. So if you need, you might want to keep some of that in stock. Heat shrink tubing, heat shrink tubing, heat shrink tubing. And a roll of Kapton tape, very useful. Let's see if I have anything else here. Locking tweezers, like soldering tweezers. They call them cross-lock tweezers. They actually, instead of normally you squeeze them to close them, you squeeze these to open them. You got a pair handy there, Mike?
Oh, yeah.
Cross-locks?
Right here.
So they're closed by default. You got to squeeze them to open them. So you
And
put
you
two
also
of them on a
have-
bench. You can hold wire between them and stuff. It works great.
They're great heat sinks. They hold the wire. Get 2 pairs of these.
I have like they're all in my toolbox right now, but I have like a half a dozen of them.
Yeah.
And
The other thing I would recommend too is getting a good soldering iron stand like this. Basically, the reason why is if you use the little cheesy stand or no stand at all, 9 times out of 10, you're going to reach for the iron and grab the business end. You're going to end up with a very, very sore hand.
This is true.
So you really want to do. The other thing with the soldering iron too is you need to keep the tip clean. So I got this little, it looks like a little scrunch thing in here. It's copper and it just sucks the solder off and clean. The thing is with soldering is if the tip is not shiny, it's not going to work. So
it doesn't transfer heat.
Right. The heat. If it's shiny, it's going to be hot. If it's dull and non-colored, you're not going to get the heat you need. So keep the tip clean. If you don't have one of these fancy little scouring pad looking things, you can use a sponge, a wet sponge, a wet piece of paper towel, and before you touch your solder to your work, clean the tip.
Thank you, Mike. We've been stressing that fact that if it's dull and black looking, you ain't gonna get a good solder. Thank you very much, Mike.
No, you will not. And the other thing too is, so I was just going to say, dude, I lost my train of thought. Oh yeah, like before you go, to start soldering a joint, you want to use flux, either liquid or paste flux, and use nothing but rosin core solder, 60-40 rosin core, or even silver solder, but do not use acid core with acid flux because it will eventually corrode. But like a nice little tub of the rosin soldering paste, let me show you my camera here. Just something like this from like Radio Shack, this rosin flux, and you need to go ahead and put a little dab on where you're going to solder, and then you touch your solder to the tip of your iron to tin it, so it gets a little bit of solder on it. Then you go over to where you're going to solder it, you touch the iron. Once the flux melts, which is very quick, it helps the solder melt and flow, and then you get a nice, clean, quick connection. Because you obviously leave your iron on there too long, you can melt things, you can damage things. So the whole point is have the right amount of heat on your iron and the flux to help clean it. A little solder on the tip of your iron, touch it, touch the solder, pull it off, and you're done.
Hey Barry, is it smart to, if you got like alligator clips, to put on each end of your track in between your joint that you're soldering to keep the heat from expanding?
And when you're soldering track, that really won't help that much. The best thing you can do, Scott, is take one of those little green or yellow micro brushes, dip it in the flux, scrub the side of the rail, and then that way it'll clean it real nice. And then what you do is you put a little solder on the tip of your iron, touch it to the rail, touch the solder, and pull it away so you'll get a little tin coat on the rail. Then do the same thing. Put a little flux in the end of your wire, tin your iron, touch the wire to the iron, put the solder to it so now the wire's tinned. Then you bend it to shape, put it through your layout surface, and then just hit it with the iron with a little solder, and it'll flow like that, and then you got a nice, clean, good mechanical joint. All right, we got a question here from Dwight Krisman. With the small space in an HO loco, couldn't we just use mostly N-scale decoders?
That's a good question. I mean, if real estate is a premium, you can use N-scale decoders, you can use Z-scale decoders. The truth of the matter is that decoders are scale agnostic. They don't care what scale they go into. Basically, any Z decoder will probably work fine in a light-duty HO locomotive, or maybe an S-scale critter, or even ON30 for that matter. The problem with using a smaller decoder is price. The smaller they get, the more expensive they are.
Yeah, and with the more modern engines, you can get away with that. But like, say you have an old Athearn Blue Box, you really need a pretty beefy HO decoder because they draw a lot more current. Now, if you remotor it with like a Helix Humper or a good CAN motor, then you can get away with going down to a smaller decoder. But most modern engines, pretty much any good HO decoder, like this one here is the TCS CAM4, right? So it's not that big of a decoder, and it'll fit pretty much anywhere. And, even if you had to mill a tiny bump out of the frame to nestle it down in there, it wouldn't be that bad. If a little bit of work with a saw or a file in here when you take the frame apart, you could fit this in just about any locomotive. And that's the biggest issue, is finding a spot for it, like you said. But you don't necessarily need to go small, because most motor decoders are small. They'll fit just about anywhere, unless you got like an NW2 or an SW 1500 or something. There you might have to do a little machine work up under the hood. But you get a small enough decoder, like this one has a keep alive in it. But if you get one without a keep alive, it might even be able to tuck up in the roof of the cab. So there's a lot of different places you could stash a decoder in a locomotive. And old Athearn Blue Boxes are about as open of a locomotive as you can get. Literally, most decoders will fit right on top of the motor with a piece of double-phase tape. Now, sound decoders, that's where the problem occurs, because they are a lot bigger. They're probably twice as
little tiny pop out of the
Here's a nice question from our buddy Bill.
Go ahead, Barry.
Now that you've done this show going with Mike, does this mean that you're leaving me for greener pastures? Bill, we'll never leave you.
Can I answer that question? Can I answer that question?
Go ahead, dude.
Bill, he will never leave the live show. He's just making it easier on me because I've whined too much to... No, all in all, it's an awesome pleasure to have you and Mike start doing these, and Gino as well, and Troy. You guys are taking a lot of pressure off my back, and it's awesome to have you guys to start participating in these hangouts.
Well, thank you very much, dude. I greatly appreciate that.
Yes, indeed.
I've got a question for you, Barry.
What's that, Bill?
When are you going to do an install on an N-scale steam engine?
Ooh, we might have to plan that for a future show, Bill. That's a good thought. Problem is we have to go buy a steam engine. None of us are N-scale modelers.
Oh,
But,
I'll send you one.
I ain't doing 30.
yeah, if you want me to install one for you, Bill, let me know what you want in it. Send it over. We'll do one of these presentations showing the install. That's not a bad thought.
Where's
scale is a little more difficult.
Has to be a Z-scale decoder because it's the only thing that'll fit in the tender. Can't put them in the cab.
What kind of locomotive are you talking?
Any of the N-scale locomotives. There's no room inside the engine for them. I have to go into the tender and then.
Yeah, even
Has to
HO
be
we put them in
Z-scale.
the tender.
Well, even HO scale, I mean, mine had to go into tender in my HO scale. Troy's got a good one for you. If Troy should send you one for sound, I know Troy's probably got several that he would like you to do for sound.
Yeah, that's something we can definitely talk about, guys. I think that'd be a great idea. And anybody has any suggestions that they would like, things they would like to see of a techie nature, please let us know, because we'll be glad to try and put together something for you guys to cover your interests. But speaking of small decoder installs, what you see in the bench here is a Bachmann 3-truck Shay. Me and Mike each have one of these for our friend Dick Sengus up in New York State. We're doing sound installs for him. I'm actually be able to fit a wow sound and a keep alive inside the tender shell here, but I have to remove the factory board. I can't use the 8-pin socket. So what I'm going to do, until eventually TCS is building a replacement motherboard, so you would pull this board out, drop in their board, and plug a 21-pin wow sound. It'll have everything ready to go in there. Just got to mount a speaker. But for now, I've traced out all the board connections, where do they go to the 8-pin socket, and there's 6 pins here. So I'm going to unsolder the 2 connectors here, solder them to the wiring harness, and then just double face tape the decoder and the keep alive in here, and then in the back of the locomotive here, I'm taking the weight out, and I'll take some of the weight off, and I'll put this little tiny Nokia cell phone speaker underneath with some baffling, so it points forward into the cab. So that's the project, which will be, I hope to shoot a video of it, but we have to have it done in the next 2 weeks before we go to New York for our clinics at the Niagara Frontier Region NMRA event. So we got some work to do.
Barry,
Yeah.
I've not to interrupt you, but I got a question to ask you.
What's that?
It is on most of the sound decoders that I've installed in a lot of my locomotives. And I've asked this question, but you haven't been in any of the hangouts, and I haven't really remembered to ask you. What is the capacitor designed for when you solder the capacitor in a sound unit? What is its number one function in a sound unit?
Well, you mean the regular electrolytic capacitor comes with this, like I say, a tsunami, right?
Exactly.
That is strictly designed to power the sound unit, so that you hit a blip in the track, the sound system doesn't reset. It's not like a keep alive where it powers the engine and everything. It's strictly supposed to be designed to prevent the audio from blipping, when you hit a dirt spot in the track. But the keep alives, which now everybody sells, NCE makes them, Digitrax makes them, Soundtrax makes them, PCS makes them. They cover the motor, the sound, and everything. So, if you have problems with track work or whatever, dirty wheels, they help, get around that problem.
So what you're saying is if you have, is it really necessary to put the capacitor in it? Because I put every sound unit that I have, even if it was Digitrax, if it was Tsunami, it came with a capacitor. Honestly, if it runs across a dirty section of track it affects everything. I mean, is it really necessary to put that in there?
Not really. I don't think there's any electrical reason it needs to be in there. But you'd have to really check with the manufacturer's instructions if you can remove it. Because correct me if I'm wrong, Mike, but aren't there a few where you disconnect that capacitor and the decoder won't work properly?
Yeah, well, what's going to happen, it's called a filter cap, and what's going to happen is your sound's going to pop if you don't have it in place. And the other thing, too, is if you hit a dirt spotted track, the decoder's going to reset itself every time. It's going to be a real pain in the butt. Your best bet is to you got to leave the filter cap in place. I mean, that's not negotiable. You have to figure out somewhere to put it. Some of my strategies for putting filter caps would be if you have another car to carry around, either a tender, or you could plug in if you're doing N scale, maybe a dummy diesel or something where you could put some of the extra electronics in. That would be one idea, but typically if you don't include your filter cap, your decoder's not going to work the way you want it.
Alrighty. So we got another question here from Almar.
Thank you, Mike.
Hey, anytime.
It says he was talking about the Evans Design model lighting kit he used in DC with no problem. Oh, okay. Yeah, I guess if it is a lighting kit, you might be able to tie that into the rectifier on the if it say it's designed to take 12 volts. Yeah, you might be able to do that.
Yeah, I mean, basically at the Evans kit, they come wired, and it's a little bit more expensive if you buy them that way, but it has a little bridge rectifier built in, and it also has the pull-up resistor in there as well, or I think they actually use a Zener diode, if I'm not mistaken.
Yeah, you could use a Zener so it drops the voltage, yes.
Right. Right, but yeah, something like that you can use. The problem with hooking it directly, because I mean conceptually you could take that Evans kit and tie it to track power for that matter, because it has the bridge rectifier there.
That's true, yeah.
But the thing is, you lose the ability to turn it on and off. If you wire up the function, you have the ability to turn it on and off. Now, in some cases, you may want something on all the time, and that's fine. You can certainly use it for that. But the whole purpose of having the different functions in the decoder is to have the ability to turn things on and off at will.
Yes. Here's a question from Arthur Morgan. Says, are decoders universal with all DCC control units? Absolutely.
That's a loaded question.
It is a loaded question, but that is the only piece of DCC that is actually standardized.
Mm-hmm.
Because, I mean, we've had, presentations and live shows before about DCC, and the main components are your control bus, which is the throttle to your DCC system, the track bus, so that's where the output of the DCC system goes to your track and goes to your decoder.
Mm-hmm.
That is a universal NMRA standard. The data that gets sent over when you send a command to throttle up, turn your headlight on, all of those packets are defined by the NMRA standard. So therefore, a Digitrack system can control a Tsunami, a TCS decoder, QSI, NCE, Zemo, as long as they are a DCC decoder. Now, I can't take a Digitrack throttle and plug it into an NCE power cab yet. The NMRA has just ratified a standard called the Layout Control System, and it will allow you to, its interface will allow you to make whatever throttle you want work with whatever DCC system you want, plus have an interface to different like control buses for like accessories, etc. Mm-hmm. So that hasn't reached fruition of people building it yet, but it's becoming a defined standard so that we can have that interface and we can pick and choose what we want, and it therefore can make even that side of the DCC systems be more universal.
So now, since you're on that subject, I was off cooking dinner, but anyways, can you take a NCE cab and the newest version of it and plug it into a Digitrax and run a locomotive?
No.
Okay.
Yes.
Because I went on the NCE and looked on their website, and it said nowhere that you could actually plug an NCE into a Digitrax or a Digitrax into an NCE, and it said it didn't say nothing about it.
Barry,
Yes.
we run our NCE on Digitrax. It's a new version come out this year, but Digitrax will not work on the NCE.
So what do you plug a NCE throttle into a Digitrax command station, Bill?
Yes.
Oh, that's good to know. I'm glad you told me that.
But it
That's the first one.
does not work reverse, though.
Right. Okay, gotcha.
Digitrax is still working on doing something to allow them to run on NCE.
Okay.
So why do they not say that on their website? That's what I want to know.
I have no idea.
Well, think about it. If they tell you, you might, instead of buying an extra power cab or something for another throttle, you might go buy a $60 UT4 instead.
No, you got a point there. You got a good point.
You know, it is a marketing thing. I mean, from a marketing perspective, it is something that says, I have a great system. It's so great. You can put whatever cab you want on it, and it'll work. But that some people buy a system because of the cab and not because of the features of the command station. So, I mean, I have a Digitrax Zephyr Extra. I have nothing but UT4 throttles. I refuse to spend $200 on like a 402 or something because it doesn't offer me anything in operations. You know, but some people are different. They like that throttle. And that's part of what this whole layout control system that the MRR is working on standardizing, is that you can do that with anybody's. Because there will be an interface box that knows how to talk to Digitrax, to NCE, to Roco, to any of the other command stations, and then that way you plug your throttle on there. It translates the communication protocols to whatever command station you want. Because as of now, if most people have NCE, if they want to do signaling, they buy either a loco buffer or something like that, or a PR3 as a USB interface to the computer, and then tie it into their own LocoNet for all the signaling accessories. But it's totally independent of your NC command station for running your trains. The nice thing with JMRI, you can have multiple connections like that simultaneously. So they set up a Digitrax one on this COM port to talk to your signals, and an NCE connection to talk to your locomotives on the track. The layout control system will allow you to do that with anybody's system. So hopefully,
with the NC system that we have, it was a new version come out the first of the year. We can do everything that Digitrax does except transpond.
Very nice. I'll have to check that out, Bill. If you got any info, send it over my way.
Switches, our turnouts and everything with it.
That's really good to know, because I know they've been talking about a lot of changes coming up for NC, and all I've been hearing is vaporware until you've told me this. So that's something I'll have to check out, because I'm going to be up in NC territory in a couple of weeks, so maybe I'll get this. I don't know if they're going to be at the event we're going to be at, but if they are, I'm going to bend some ears.
Yeah, well, if you would, because the way I look at that is NCE is basically jumping on board with Digitrax, because I mean, I don't want to bump any heads here, but Digitrax has came a long way in technology.
Oh yeah.
NCE hasn't. And
right.
If they can jump onto a Digitrax system and run their cab on a Digitrax system, I mean, I can't say that's wrong, but it should go the other way as well. You know what I mean?
Hey,
Yeah.
Mike.
The problem is that, like you said, NC was so far behind times that they had to do something because Digitrax started out selling them. So they worked on to do all the conversion, and now they're working supposedly with the NMRI and Digitrax to try and get it all set to where you can run any cab in any system.
That's the layout control system I'm talking about, Bill.
Right.
I know they demonstrated at the national show last year.
Yeah,
Hey,
it's
Mike.
an LCC.
Yes. Can you move your camera so we can see what you're doing?
Oh, yeah. I'm just. Oh, it's a mess over here.
Yeah, we got a couple quick questions here that maybe we should look at getting into talking about the decoder install.
Okay.
I want to show some stuff. I mean, I talked a little bit about the Shea project I got here, but I want to talk about what I did with this GP30 plus, let you show your the install you've been working on there.
All right, hang on a second.
Sure.
I lost my camera.
Well, when you get it back, I'll switch back to you. Now, let me show you what I worked in this one a while ago here. This was a rather problematic little child. Like I said, this is an old Proto 2000, Bachmann Spectrum, I'm sorry. So I put a beta test of a WOW diesel in here and promptly creamed it to death the first night. Apparently, the frame conducted the power from the track to the motor. So what happened was I pinched a wire. Let me see if I can zoom in on this a little bit better for you. There we go.
Been there, done that.
Oh yeah, I mean that's not hard to do. There's the other one. Yeah, so afterwards I learned a few tricks and fixed it. Get that out of the way. By the way, if you ever go to LL Beans, buy these little plastic lure containers. Great for storing parts in when you're working on a locomotive.
Very cool.
Alright. These split frames are always a pain in the butt to work on. But, there we go. Pop that out. So as you can see, in here I did a little grinding just to make clearance for the wire going down to the bottom motor contact right here. The entire thing is insulated in Kapton tape all the way across here and up the side of the motor to help protect it from chafing. What I did on these here, the truck contacts here, the contact plate for the back of the wheels is screwed into the frame here, so I screwed the wire right on here. There was a hoop going from here to here that touched the frame. That's how it got power to the motor. The motor wires contacted both sides of the frame. So that's what one of these wires got pinched by the frame, and that's what shorted out and blew the decoder. So first thing I did, I put the power wire to here, and I cut the hoop off so it no longer would contact the frame. And then, like I said, I went and insulated this side of the motor from the bottom contact with Kapton tape. And the top one here is also insulated. But yeah, I had to do a lot of just filing along the top edges here, like right in here, just to relieve the sharp edges so it wouldn't pierce the wire anymore. I did here also as well, so the wires wouldn't get mangled. And then that solved my problem. It works fine now. So that's a good technique to learn, especially when you have these split frame designs. Make sure you file and leave room for the wire, because it didn't take much to cut through this thin insulation, and use Kapton tape. Even if you got to put a couple layers in there, you give it a good physical insulation, as well as electrical isolation. and then try and get your power pickups off the frame. And like these, like I said, there was a little, I don't know if you can see it there, it's a little screw right there, and that's where I just wrapped the wire around it, and I cut the hoop that went from here to here off, so that isolated this from the frame completely. But yeah, anytime the motor touches the frame, you want to isolate it and run discrete wires, or else you risk frying your decoder, you know, by mistake. So I got a few more of these spectrum engines I got to work on, and then I'll be doing the same thing, just filing, you know, anywhere where the wire might touch.
Mm-hmm. Yeah, that's a good point, Barry, that you make there too. The motor has to be electrically isolated from the frame, and the best way to do that is to any metal part of the motor, get a continuity meter or get your own meter, and just make sure that it's open.
Yeah.
And if there's any shorts, just wrap them in Kapton tape.
Yeah. Yeah, you can pick up a meter like this, like $5 at Harbor Freight, you know.
Mm-hmm.
I keep a couple of them laying around just for that. So.
Yep.
So what you got there, Mike? Oh, look at that. Look.
Yeah, that's my little RS2. Now, you know, it's interesting too in terms of picking your first hardwire installed locomotive. This here is actually the first one I ever did. It's a 1960s vintage AHM RS2. And the nice thing about this, besides the lovely paint job and the prototypical with handrails and everything else, is that the motor was already isolated. And I'll just pop this open real quick. And I redid this install too. Actually, you can see that it's a much cleaner, nicer install. It's important when you do an install that, oh, my hand's in the way. There you go. That a little better? Yeah. I'm still learning how to use the camera.
Go the other direction.
Oh, the other direction. Like, hey, like that. Yeah, gotta go backwards. It's like working in the mirror. Right. So, I mean, basically, I have pictures when I did this for the original install, and there's wires all over the place, and I was afraid to cut the wire too short and everything else. It's just as bad to have the wires too long in an install like this. What you want to do is cut the wires just right. And the thing is, if you do cut it too short for whatever reason, you can always splice wires together. It's really not that hard to do. And when you do a splice or you do any kind of joints, you want to use the shrink wrap tube, shrink tube. Like if you look at the resistor right here, the resistor and the blue wire, you can see that there's shrink wrap tube around that as well. That's the key piece in order to make sure everything stays insulated. Now with this installation too, it's basically a metal frame, and you just have your motor here, and your pickups are on the front truck. So it's pretty straightforward. It's a pretty simple install. What I ended up doing in order to put the light in, I used a piece of styrene to make little light posts, and I mounted LEDs inside the light posts. The other thing I did was to use a piece of styrene down the bottom so that the decoder itself didn't interfere with the motion of the front truck. So you can find out, you know, basically don't be afraid to do a little bit of modification. Barry did a little milling on his frame. I built up a lot of the styrene structures here on this particular one. Let me switch up to the one I was working on tonight, the BL2. And I was just doing a couple quick test runs. Now the important thing to do when you're doing a test run on a DCC install, don't put it on DCC first. If you make a wiring mistake and you put it on DCC, you get full track voltage to the machine and you smoke your decoder. If you make a wiring mistake on DC, you bring the voltage up slowly, and if the thing doesn't work right at low speeds, then you just stop and you examine what you did. It's a way to save you the aggravation of going and getting your decoder replaced. And
Absolutely.
what I've done on my layout here, my little test layout, is I have a couple track sections with toggle switches, and I can switch from DC to DCC really easily. So it's just a double pole, double throw toggle switch with a center off position. That's important too, because you don't want to mix DC and DCC.
Now, since you're on that subject there, Mike,
Sure.
when somebody buys a locomotive from a swap meet or even a brand new one, should they run that on a DCC test track to make sure it works before they install a decoder?
Absolutely. I mean, the thing is, if you don't test it on DCC, first of all, you don't know. Like, for example, the BL2s that I have here, the biggest problem they have is they're an Athearn clone, but the axle gears are notoriously splitters. So you basically have to take the wheels out and put new wheels in. And if I didn't run out DC first to find out that problem, I would have my decoder install done and everything else, and then the locomotive would run like crap. I mean, if it doesn't run good on DC, it basically is not going to really perform that much better under DCC. You really, and especially steam engines. Steam engines are really, the side rods are notoriously bindy. If you're going to do your first hardwire install, I would recommend that you stick to diesel because it's a lot simpler. And I would recommend that your first install, if you do a hardwire install, would be on some sort of covered wagon, either like a BL2, an F unit, an E unit, something like that. Basically where you have a lot more play to put the stuff in. And as you get better, you can move towards the hoodie units and smaller diesels, and then to steam. Steam's very finicky, and you really want to make sure that runs great on DC before you go to DCC.
Now, my other question is, when you get let's say you're going to hardwire a decoder in, and it's DC, right? When you buy it,
Mm-hmm.
should you? Okay, for one, make sure it runs on DC. Should be, and let's say you want to put a sound unit in it. Should you wire it up and then plug a regular module or motor control decoder in it before you go to sound, or does it really matter?
Well, that's a good question, dude. And what happens is most sound decoders, I know that the TCS uses the Justy 9 standard pin out, just like this one here. I believe Digitrax does the same thing. So it's modular. You could try it and wire it up. It's the same wiring, same color code. Try it with a regular motor decoder first. Make sure everything works the way you want it to work. And if that's the case, you can unplug that module and then put the sound decoder on there, and then run on the TCS design. It has a Justy 7 pin on the other side, which has the speaker and the filter capacitor and such. And you have to find places to put there. The hardest part of a sound install is finding a place to put the speaker and making sure that you have enough of an airtight enclosure so it sounds good.
That's absolutely true. And think about it this way. If you put, like, say, a cheap $20 Digitrax, like a motor decoder, in that locomotive and you pop it, you're not popping a $100 sound decoder. So it was a very good point that dude raised earlier. Why don't you do that? And it makes sense because, like I said, if you blow a $20 decoder, okay, you're out $20. You blow a wow sound, you're out $100.
Mm-hmm.
Or you blow a soundtrack, you're out $100. So yeah, I would definitely agree with that. And like Mikey said, the biggest thing with doing sound is with speaker enclosures and stuff. Like like in this locomotive here, it's my GP30 body. What I'll do is I'll put a speaker enclosure in the back here, okay? And because this doesn't have open grills, what I'll do is I'll build a little box up with the speaker so it points down and comes out around the rear gear tower. And that way it will get the sound out. The biggest thing with sound installs with speakers is you need to isolate the front of the speaker. So in this case, you need to isolate the front of the speaker here from the back, because if the sound waves reach each other in phase, you barely hear any noise because audio, acoustically, they cancel each other out. The speaker goes out, and the speaker goes in the back. The sound waves just go in sync. They fight each other. You want to have enough distance from the front to the back so the sound arrives out of phase. So typically, if you have open grills in the top of your engine, you mount it with the speaker facing up. You build a baffle around it and seal it to the body so the sound goes out the grills, and it'll come around and reach the backside through the gear tower. So now you have sufficiently long enough path. Conversely, if the top grills are not open, you flip it and point the speaker down. Now with a transducer like this, that's imperative that you do that. But with a regular cone type speaker, you can get sound out of the front or the back with very little difference. So your best bet is to point even if the sound's going out the top, put the magnet in the back of the speaker in the enclosure to save some physical space. And that way the sound will come out the back of the speaker and go around, and it won't cancel out. But these little
very good input, Barry. Very good.
Yeah, these little Nokia, they're called a transducer type speaker. You can actually mount these, hard mount them to the shell of a locomotive, and then just seal around the outside edge, and the shell becomes part of the sound generating mechanism. Because this is not a cone type speaker where sound comes out the back. You can see the back of this is sealed completely. So the sound only comes out the front. So I can literally take like super glue and glue this to the shell of the locomotive and then just seal the edges, and then it'll sound great. If I played it like this, you wouldn't hear nothing, but literally if you just took it and put it in your hands like this, now you're blocking the air from the front to the back, it'll triple in volume. So it works out very good to, to isolate front from back, even with these.
I worked in a repair shop that had they installed stereo systems. I mean, high-tech stereos. And, if it comes to common sense, if you guys want to know how sound works, just go watch some YouTube videos on these guys that are building high-tech stereo systems in their cars. It'll tell you so much when it comes to putting a sound unit in their locomotives. I mean, I learned a lot from that. Exactly what Barry is saying. I mean, yeah, I know exactly what you're saying, Barry.
Well, if you check out Bruce Petracca, Mr. DCCU, I think .com is the website, DCC University. He had a whole presentation and a video called Getting the Sound Out, where he discusses all these things, how to direct the sound, how to isolate, the speakers properly and baffles and everything to really get the sound out of your locomotive effectively.
Barry,
yeah, Bill.
In the back there, I don't know if you can see it or not, but there's a 15-inch woofer sitting with a 6x9 facing the opposite direction.
Yes.
That causes the sound to travel inside of itself instead of canceling itself out.
Yeah, that's a close coupled speaker design, I think.
Yes, it is.
Yeah, you can actually, I've seen guys Laurie McLean from Australia has done that. He uses isobaric configurations where he builds a single enclosure, okay, it's a square enclosure, and he had two 1-inch high bass speakers facing each other. but he had the polarities reversed. So when this speaker went out, that speaker went in, and they just went like this back and forth, and the sound came out the back of the enclosure, and it was incredible how much volume and bass you got out of that thing.
That one right there, big white box, has two 15-inch. That's setting exactly that way.
Yeah, and that'll generate some noise. Let me tell you what. But yeah, you're absolutely right. Real world examples, like Dude said, there's so much to learn from audio engineers, and I've seen a lot of discussions about speakers trained from audio engineers. So
That's so true, Barry, because you know what Dude said. For example, my home theater system, I have 3 of them. 2 of them have very distinct audio characteristics because they're designed to go in phase or out of phase. Meaning, just like you described, the speakers can go, they're front and rear speakers on a single cabinet, and they can be out of sync, meaning both fire, one end fires inward, the other fires outward.
right.
Or they can both fire outward simultaneously and inward simultaneously. And you get very different sound characteristics, and at a certain point in crossover, you can actually cancel the sound out.
Yeah, yeah. So, Mikey, we got a question here from Bill. How elaborate can you get with DCC, and basically, when is enough enough?
Well, that's easy. Enough is never enough.
I knew you would say that. That's why I figured I'd let you take that one first.
Basically, you have the potential to hook up relays, animation, automation, routing. You know, I'm thinking in terms of you should be able to take a small camera and control that through DCC and have it send to a webcam.
Yeah, you very well could do that. I mean, the thing is, when enough is really, I mean, that's depending upon what you want to do. And like you said, enough is never enough if that's what you want. It's a very personal decision. If I don't want my engines to make noise, and I don't have a very sophisticated layout, and I don't mind using ground throws, why do I need to put in accessory decoders and servos or tortoises? I don't need to, if that's what I'm happy with doing. Some of us who are techno nuts gotta have the latest and greatest, you know, and so we're the guys that go too far. Like if any of you know Laurie McLean, his videos of his animation started out in O scale, simply with a conductor on a caboose waving an LED lantern in his hand, to bells that are synchronized with a gear motor to the sound of the bell. So now he's got a working sand tower, a working coal tower that actually drops the chutes, puts coal in the tender of his locomotive. The water spout comes down and puts water in the tender. Well, not real water, but you know, the spout comes up and down. He has dancing girls in his saloon. He has a dog doing something out on the front porch. He has a guy in a rocker rocking back. I mean, he is the absolute example of enough is never enough, because he's still going. And he said he just ordered a bunch of stuff to keep adding more animation to the saddle sore Gulch layout of his. So
yeah, the best way to answer Bill's question is each man makes his own decision as when enough is enough, and when you cry uncle, then you're done.
Yeah, exactly. Yeah.
And I would suggest that it has a lot to do with what you're trying to capture as a modeler. I mean, if you model a timber layout, then most things were manually operated by those people, and replicating that won't require a lot of computer control. But if you're trying to replicate a Class 1 mainline with CTC control, then you're going to have more things to accurately model that. So my opinion would be that it depends on what you're trying to recreate as a modeler, how much electronics you need to incorporate. You can always incorporate, you know, more and more and more, but you will need a certain amount of electronics depending on what you're trying to recreate.
You're absolutely right. I mean, just like you said, you want to model a Class 1, you have signals. You know, if you want to run signal, you want to run absolute block control, CTC. I mean, that all has a varying level of what you need for electronics. I mean, you could have signals that just turn on and off with like a reed switch, just so the train passes a signal and it turns it red, and that's that. You know, and you don't care that it has a yellow or a you know a medium price. You don't care about anything. You just want the light to go red, yellow, or green.
Yep.
You want to recreate something that in the real world has a tremendous amount of, like a class one railroad with CDC and signals and you know, et cetera, et cetera, et cetera. If you want to recreate that with any accuracy, the real prototype railroad had a degree of electronics involved in making that happen. You will need a certain degree of electronics, and DCC, and probably even more important than DCC, is JMRI, gives us the ability to recreate that at such a high level.
Oh, you're absolutely right. Now, I have a question here from Sean Hendricks. What engine do I get for a dummy Atherton Blue Box engine? So I'm assuming Sean would like to make it motorized.
Well, the easy answer for that, Barry, is to buy a motor version of the same engine and change the shells out.
Yeah, you could do that. I mean, you can also. The thing is, if you don't have any of the pieces, like the gears and everything, by the time you buy all the parts, you probably could buy the same locomotive, and like Mike said, just swap the shell. But if you have like a locomotive that's damaged, and you can salvage the gear towers and stuff, you can go buy like a helix humper and flywheels and stuff, and then attach them into the chassis, and then you should be good. You know, you might have to buy like drivetrain components, like your dog bones or something like that. But you know, it depends on how much you have. You know, the more you got to buy, the less useful it's going to be to do that.
Yeah, and John, the other thing that we realize too is that when you get the replacement, the motorized version, you change the shells, you can always eBay the dummy off. So it's not a total.
That's a good point. Yeah. Now we have a question here from Matt May. How many speakers can a sound decoder handle, and when there's room for more than one speaker in a locomotive?
Mm-hmm. Now, I mean, basically, the sound decoder will handle, and it's basically a value in ohms. So typically, your sound decoder will handle somewhere between, for TCS, it's between 4 and 32, although it's optimized for 8. I know some of the Loc sounds use 100 ohm speakers. The bottom line is you basically want to try to find that sweet spot. You can mix and match 4 speakers in series and parallel. You can have 2 series of two parallel speakers each, and that will equal 8 ohms, and that will work. So you can have like 4 speakers going if you can squeeze them all in.
Yeah, that's very true. Yeah, like you said, the more you add, the more you have to look at doing serial and parallel combinations. Because like 2 8 ohms in parallel stays at the 16 ohms, but in series, no, they're 4 ohms.
4 ohms.
And in series, they're 16 ohms.
Right.
So then if you put 2 in series at 16, and then another 2 in series at 16, you put them in parallel, now you're back to 8 again.
Right, exactly.
What you have to worry about is then how much wattage can my amplifier deliver. Mm-hmm. So at higher volume levels, driving 4 speakers is going to work your amplifier harder because you're driving, you know, more speakers. So here's something. Troy, he just popped up a little chat. Then ever used any Cube speakers? And let me see what it said there.
You have to seal both sides.
Yes.
Yeah, I've used sugar cubes. The bigger sugar cubes, as long as you have a nice airflow to get the sound out, they're pretty decent. The 16 by, I think it's 16 by 11 millimeter. I use that guy. You do have to make sure that the seal's solid between the enclosure and the speaker itself. That's the only thing. You can just throw it basically anywhere at that point. I
Well,
tried the smaller sugar cube. I think it's the 13 by 10, and I was very disappointed. I didn't get the kind of volume I wanted. So for the sugar cubes, you want to stick to the 16 by 11 or bigger. Or I think that might be the biggest one they have. There might be one just a hair bigger.
question for you, Mike. I mean, the sugar, were they like a cone type speaker, or are they like a transducer like this Nokia?
They're transducing.
Okay. You see, sometimes the transducers around the edge of them, and it's hard to see, but around the edge here, sometimes, there we go. There's a slot. I don't know if you can see that slot there. That lets air get from the front to the back of the speaker, so sometimes you have to literally like glue an enclosure around the edge here, or if you're acoustically mounting it to the shell, to seal those slots to prevent sound from reaching the front and back. And that's common for sugar cube type speakers. This actually here, this is a Nokia cell phone speaker I got off of eBay from China for $1 a piece. I bought 10 of them. What's that, Troy?
This is a sugar cube speaker. It's the super bass for N scale.
Oh wow.
There's a speaker that sits on both ends of it. That's what I was kind of wondering. Do you seal both of the open ends of it?
You probably should, yeah. But since if they're facing each other, you'd have to reverse their polarity so they don't fight each other. If they're facing in the same direction, you wouldn't have to do that.
Right.
I'd have to really. I mean, where'd you get that from?
I bought it online. To be honest, I really can't remember their website right offhand.
Yeah. Okay.
But these ones, they do face each other.
Okay.
Oh yeah, I can see it. Yeah. That's the only thing is if they're facing each other, you have to reverse the polarities on them so they're out of phase. That way they work together. If you polarities the same, both are going to go out at the same time, and they're going to fight each other. So you want them to go opposite. That if you seal both the front and back face, or at least the back face, and leave the front face of the frame open so the sound can come out, that's what they call like an isobaric configuration.
Right. Yeah, now, I mean, I think the thing is you're either going to get a lot of real loud sound if it's wired right, or if it's not wired right, you're not going to hear hardly anything, and all you have to do is just reverse the leads on one of the speakers, and that should fix it.
Okay.
Yeah, like I said, if you hold the speaker in your hand, okay, and then you won't hear that much. You seal it like, like this, so the sound can't get from front to back. All of a sudden, you go like that. Now the sound volume gets really loud, like this. Yeah, camera. Yeah, that's because the trick. Now the sound's got to go this way instead of just around the edge of the speaker, That makes a huge difference. That's one thing I learned about sound installs. Keep the front sound from reaching the back sound in phase.
Mm-hmm.
Obviously, at the frequencies we're talking, if you can get it to go, the sound has to go from here to here, you're fine. It's way too long of a path that they won't arrive in phase. But if it's only got to go from the front of the speaker to the back, as you get the speaker sitting on here in an open shell, it's going to fight itself and you won't hear much volume.
Okay, the reason why I'm asking is because this is for a sound car, and I was told that you're supposed to glue it down so that the open end is down inside the sound car and seal the other open end, so both open ends would actually be sealed.
So
that's what I was kind of curious. I don't know how exactly that right there would actually work. That's what I was kind of curious about it.
There must be porting on the. I'd have to really look at it closer. There must be port. Did they say which side has to go down?
No, it does not. It just says, it'd be like if I'm holding it right now, that would be the actual one of the two sides actually that would go down on there. The enclosures actually, it's not even like a plastic. It's really thin. It's brittle as all heck.
That'd be some kind of composite material then, yeah. I know George at TVW Miniatures uses wood enclosures sometimes because they give you a totally different sound to his Sugar Cube speakers. He's definitely a really good source for Sugar Cube speakers. Yeah, I'd have to look at, get a really better look at that speaker and then find, if you can get the manufacturer's name to me, I can take a look at, even send me the instructions, I can take a look at see what it says. Because I can't think you'd have to seal both sides, but because then how's the sound get out?
Yeah, see, that's what I was thinking also.
But see, also these transducer type speakers, you can, like I said, you can rigid mount the back of the speaker right against the shell. So maybe that's what it's doing. Maybe the back of the speakers are rigidly mounted to that frame, and then if you seal the inside and set the speakers so they work in unison, now the frame becomes a bigger piece that can transmit that sound into the frame of your like your locomotive or your sound car or whatever, and therefore it can get the noise out, acoustic coupling of the speaker frame to the actual body of the thing you're putting the speaker in. Because literally, if you mount it like that, the shell becomes part of the speaker array.
Yeah, I think probably to clarify a lot of this, because I've experimented with a lot of this with speakers and stuff, and I don't think a lot of people realize that the enclosure or the housing for a speaker is actually the thing that actually transmits most of the sound. So having your speaker out in the open and listening to it is going to sound totally different than what it does whenever it's enclosed and housed.
Mm.
Yeah, if you look at some of Laurie McLean's videos on his speaker tests, I mean, he graphically shows you all these different kind of speaker configurations, and he has a test board showing you what an isobaric configuration looks like, a acoustically coupled high bass. I mean, check out some of his videos, and that you'll learn a lot about how speakers work. And like I said, check out Mr. DCCU, Bruce Petracca, and his video on getting the sound out, because that is an education unto itself.
Hey, Barry.
Yes, sir.
I don't mean to change the subject, but I have some questions. I know that you're really involved with a lot of the wow sound stuff.
Right.
Recently, in going through videos on YouTube, I've run across a couple of videos where a couple of individuals that we know pretty well have had issues installing and have put up wow sound fail videos. I'm just curious if you've had any contact with them or understood what those issues might be.
I have not yet. I mean, the only person whose videos I've actually seen is Derek, and I spoke at length to Derek to find out what was going on. And to tell you the truth, neither of us were convinced it was a decoder problem. He would try and completely remove the Athearn Genesis factory board from that locomotive he did his videos on, because come to find out, that locomotive was supposed to be brand new in the box, and we don't think it was, because there was a screw missing holding down one of the motor mounts, and the screw coming up from underneath that secured the fuel tank to the frame had been stripped out and replaced, and the screw that was put in was almost touching the armature of the motor. So we don't quite know what was going on, but now, obviously we all know his I think it was his mother passed away. So wait till he gets back in swing of things, but he was going to do a hardwire install and completely factory electronics, and that way see if there's any better results with that. And that is one thing that we never really touched on tonight, that sometimes it is better to ditch the factory boards. And I know, especially with Bachmann, because Bachmann, because they sell a lot in Europe, they include a lot of filtering components like inductors and such on the board that can play havoc with a DCC system. So your best bet, a lot of times, is to pull the factory boards out.
Right. Especially back EMF. I mean, basically the inductors and the capacitors, they're supposed to reduce the motor noise and RF interference. and back EMF is relying on some of that too to do what it needs to do. Yeah, to slow the motor down or speed it up based on what the motor's doing and what the locomotive should be doing.
Yeah, you're absolutely right, because that totally screws with it. Because especially with, like, I know with TCS for like the wow sound, steam and diesel, they rely heavily on measuring the back EMF to control how the sounds are put out from the engine. I mean, the entire auto notching of the diesel is extremely dependent. Same with the steam. I mean, if you load up one of the wow steam equipped diesels, you'll hear the chuff get real hard and heavy. A lot of staccato notes to it because it's actually playing different chuff recordings rather than changing the volume or anything. It actually has a set of recordings that are done under load. So it measures when, oh, I'm getting a load on my engine, I need to switch the sounds I'm playing. Same with the diesel. It knows that, oh, all of a sudden I hit this really steep grade. I know I need to go from notch 2 to notch 6. So it knows to play the notch 2 to notch 6 transition recordings. And so back EMF is very important to fine motor control as well. So anytime those components are on those boards to filter out EMF and everything, you want to get rid of them. Some people clip them off the Bachmann boards. I find it just easier to pop the board out and hand wire it. I mean, as you've seen with what I did with the GP30 here, it's not that hard of a rewire. Once I figured out what the problem was, you know, I could have put little tabs on these wires and put them right on the screws in the truck there. The motor, I literally unsoldered the connection because it had tabs going up that touched the side of the frame. That's what this spot in the frame right here was for. A tab on the motor touched to pick up power. So I just unsoldered the tabs and soldered the wires in place of them. And the rest of it was pretty easy, and the rest of it's all lighting stuff. So up inside the shell here, it's hard to see, but let's see. In there, I just used a little dot of the wrong way. Yeah, I used a little dot of that clear gel and taped the wire down to hold the LED in place till it's set, and did the same in the rear. And this is like 38 gauge magnet wire. Got a built-in resistor, and these are 0402 LEDs, and it looks really nice when it's lit up. So it's not that hard to do. I mean, especially with these, you know, even an 06, 03 LED would look good in here. And like I said, use some of that clear gel tacky glue from Aleene's, put a dot over your light lenses, bend your LED on an angle, push it up against there, put some blue painter's tape to hold the wires still, let it dry. And then it's nice and clean. You know, it keeps the LEDs in place, and then you just run your wires through your decoder. I mean, if you spend like, what did we spend, like $200 on those LEDs, Mike?
Yeah.
And they ended up being like
$1 each.
Yeah, about $1 each, all soldered up with the resistors, and color-coded wire too. I mean,
yeah, that was definitely worth it. You can probably get them on eBay if you look for 0402s wired for probably about maybe 80 cents each, but they won't be color-coded. They'll use the same wire for both sides, and you'll have to figure it out.
And you got to solder. They'll give you the resistor, but you got to solder the resistor in. So for the extra 30 cents, they soldered the resistor in and gave us color-coded wire, so we know the polarity of the LED, you know, which helps.
It's definitely worth it.
Oh yeah, if you get.
But don't rule that out. I mean, I'd hate to see people lock themselves into something like that. I mean, the truth is a lot of the stuff is very, very cheap when you buy it straight out, like a bag of 0402s.
Yeah.
You can get several hundred of them for dirt cheap.
Yeah.
And if you're good enough to install a decoder like you're doing there, Barry, these small wires and stuff, then surely you're talented enough to wire up an LED.
Not one of them, Mike. I've tried it to death.
Not 0402s. No.
I can barely see them things.
I know. It takes those special glasses.
Yeah. I mean, I'm 0% with 0603s, but I'm 0% with 0402s.
Yeah, I've tried it, and literally, it stuck to my soldering iron one time, and then solder floated, just dropped on the floor, and that was the last I saw of it. I mean, it is
like
literally like the head of a pin.
They're like a dust particle.
Yeah, pretty much. Yeah, I mean,
Try it though. I mean, what I'm trying to say is, you know, if you have the right equipment and you have a small soldering iron with a small tip, and
that's what
you have some good magnifying glasses, and using double stick tape on your bench to tape them to.
Oh yeah, that's very key.
Yeah,
But I mean,
you know, like you're talking about spending $200 on a bunch of wired ones. I'm actually a little cheaper myself, but you know, I just don't want people to rule out the possibility of trying it themselves.
You see how tiny that is? I mean, it's hard to tell, but how tiny they are.
Yeah, I can hardly,
even
through here, I can hardly see them, you know, because the clarity isn't very good.
Yeah.
Hangouts, but
yeah, these things they're barely bigger than the wire.
Yeah, I successfully soldered those 0603s as well, and all I'm saying is I had the option to buy them wired or unwired, and the unwired ones were so much cheaper. I just
yeah, no, you're absolutely right.
What I went for. So
I might try it at some point because I have them. I can always unsolder them and solder a couple of them to play with.
If I had your money though, I would buy wired ones.
Yeah, well, put it this way, we split them, so it was only $100 each. You know, we each got like 100 LEDs out of it, you know, so that wasn't too bad. And I've seen Warren McLean go bit, and he solders in 04 I'm like, dude, you're like 90-some years old. How do you do that?
It's incredible.
Hey, dude, I picked this soldering iron up right here.
Nice.
On Walmart's page for $59.
Wow.
And it comes with your stand, and it comes with the different kind of tips and everything. But you know, you don't have to spend a lot of money if you shop around.
Nah, you're right.
You know, like I tell everybody in my videos, you know, do research.
No, you're absolutely right, Scott. I mean, if you look at hard enough, you can get a really nice Weller soldering iron for like $50. I mean, it's not quite as like temperature controlled as that, but the one thing I found with the Weller soldering irons and the difference between cheap and expensive soldering irons is that like a Weller has a copper tip that's, you know, clad, whereas like you go by the Radio Shack iron like I have, it's an iron core tip, so it doesn't transfer the heat as well. That's primarily the only difference in the a good versus a cheaper soldering iron is that tip. A copper tip will transfer your heat so much faster. It'll heat up quicker and everything. So
I believe too, though, Barry, that you get what you pay for with soldering irons. If you buy cheap, I know I used to do that a long time ago when I was a lot younger, and they wouldn't last very long, so I'd wind up buying more of them. And you're right about the Weller. I've got two Wellers that I've had for years, and they're just an awesome soldering iron.
Yeah, I like the I have like a adjustable wattage Radio Shack iron. It works pretty good. The problem is because it's an iron tip, it corrodes a lot faster. And I go through tips, and I have to mail order them. I can't buy them in the store, which is a pain in the butt. So I'm thinking of replacing it with a Weller iron eventually, but it does the job, you know. It gets me long soldering what I have to solder, so. So, well, Mikey, is there anything you want to cover before because it's 11:45, it's almost time to wind this puppy down.
Oh, yeah, you know, let me show you a little trick here, real quick. All right, you have your Justy 9 connector here. Oh, I got the wrong side again? Yeah, I do. Look at that.
Yes.
Okay.
Bring it down to the camera.
I have to be better doing this weather girl stuff here.
Yeah. A little further down. There you go.
Anyway, with the BL2s that I'm doing here, I only need two functions. I need a headlight and then the rear headlight. So I don't need the extra function. So So typically what I do, because I always want to make sure that I can reuse the harness at another time, or if I decide I want to put marker lights on the BL2, is I always make sure I don't have the purple and green wire off totally. What I typically will do is just cut them off about an inch out, just like that. Get rid of that. And then I take my 6mm heat shrink tube, get myself a nice little chunk of it, like that. There we go. And I feed everybody in here. Because we were talking a little bit about heat shrink tube. It's really easy to use. You just cut a little bit off, and here, watch me thread the needle here. Oh.
Well, we could if your hand was out of the way.
There, is that better?
Yeah.
Yeah, you gotta help me here with this.
There you go.
That better?
We should have Van White helping Mike out here.
You need to look wherever your screen is, Mike, because you're off to the bottom left corner of your screen.
There it goes.
There you go.
All right.
So you just put them all together in a bundle and then seal it?
Yeah, I'm going to get this. One more. There we go.
Now, I'm not real familiar with that harness, but does that harness not have the clips within the plastic head that you're able to just pull the entire section of that wire out of that harness? That many of them have the clip.
Yeah, you probably could. If you would need the tool to put it back in if you wanted to.
Yeah. This is easier. No, it's not. It's easier just to pull it out.
I know the ones that I've done, you know, if you have like a lot of wires and you don't have a lot of room, that it actually works better to remove those wires completely from the harness so you don't have to do this. But I'm not shooting down what you're saying, Mike. I know there's a lot of alternatives and a lot of ways to skin a cat.
Oh, wait.
I'm thinking of space myself.
What about a frame? Here we go. I'm in my banner. Camera fell. Oh, look. You get to see my belly. Yeah, so I mean that's one thing that I did it again. Let me put.
There you go, right there. There you go.
All right, that's perfect. Yeah, basically all you do is just give it a little heat. Whoop. I don't know if you can see this shrink down. This will shrink down pretty good.
All right. Yeah, that keeps the wires nice and secure. Then if you ever want to get to them, you just take off the heat shrink or pull one of them out and solder to it.
Yeah, just pull it out, splice something on, you're good to go. Now, the nice thing about this, too, is if you're really slick, you can use this as a drawbar. And let me show you that real quick.
Oh, yeah, you've done that before, yeah. To connect, like where you have electronics in like another car.
Oh, there they are. Here we go. There you go. See that there?
Oh, yeah.
Between the two, that's a bundle of wires. Basically, I need it because it's a four-wheel drive car. Pickup's horrible, so I basically put in a pickups in the second car and just brought them over through the drawbar, which is just a bundle of wires.
Yeah, Mike likes some rather interesting things with DCC in it. Now, here's another tool you guys should think about grabbing onto. You can get these cheap at like Harbor Freight, and they're good for small wire. Don't use them anything big. It'll destroy them. But you literally just put your wire in the jaw and squeeze down, and it retracts, and it strips the end of the wire off. And it makes really quick, clean work. See, I have a small piece of wire I can show you here. Yeah, right there. So you just put it in there roughly and squeeze it. So you see how much wire you want sticking out. Just go. There you go. Stripped wire. Nice and easy.
Zippy-doo.
So you can get these for like $5 at Harbor Freight. I used to buy them at train shows. The guy wanted $15 for the same bloody tool, just it was blue and yellow instead of red and black. I found it at Harbor Freight now. Now for doing regular like layout wiring, I have like a $30 Klein wire stripper, and that thing's the cat's meow, but it doesn't go below 16 gauge wire. These things are self-gauging, so you can strip like really fine wire with them if you're careful. Well, folks, we got one more question here. It says from Philip Wyman. It says, if copper is the best conductor, then why are rails not made of copper? Well, for one, copper corrodes. So, and the corrosion is non-conductive. That's one of the reasons nickel silver makes the best rail, because when it does oxidize, the oxidization is somewhat conductive compared to brass or steel or copper. So, you know, plus copper rail would eventually get that funky green patina that like copper pipes do, and that is not prototypical. So.
Well, yeah, but I mean, if you look at copper as a conductor for electricity, it's always sealed in an insulating jacket, which keeps the corrosion.
Or like, you know, some kind of conductive like silver plate, something like that.
Yeah, I mean, there's two. I mean, for example, copper's a soft metal too, so it's not going to really hold its shape or stand up to a beating. Like if you stand on a nickel silver rail, it won't deform, but on copper you probably could deform it. Brass actually has a bunch of copper in the alloy, so that's probably the closest thing you can get to copper track if you really wanted it. But again, the reasons you said too, basically tends to corrode, and a lot of folks, they like the silver railheads because that's more prototypical.
Well, it really is. So, you know, it's just like, you know, anything you want to try and make it prototypical, but there's a lot more maintenance headaches if you don't. If they had like copper rail that was jacketed with like a tin, not a tin lead, but some kind of coating like that, it will keep it from corroding, but then you got to worry about the wear factor on the surface of the rail is eventually wearing that coating off. So it's definitely it probably would not be physically feasible to use copper, but it is definitely a much better conductor than anything else out there, including thermally.
Oh yeah,
copper is a great thermal conductor. I mean, copper heat sinks are way better than any other kind of heat sink. I mean, I used to design amplifiers that had like 1,000 watts. They were like industrial RF amplifiers, and we used all silver plated and silver flashed copper heat sinks because it was so much better at you know, clearing the heat away from a transistor. So, well, gentlemen, it's been an interesting evening. I mean, we had a lot of great questions, a lot of good feedback from the audience. So hopefully everything continues to work on its merry way. You know, I'm very happy with the way things turned out for our first show. So.
Yeah, Barry, you know, and I just wanted to add, you know, I was so excited about you and Mike putting these together and getting them on the air for everybody, and I'm so looking forward to you guys doing this every month. And
yeah,
I hope that you guys can include me when you can, because, man, these are so informative. And I hope to get to work on some of my electronic stuff, and maybe I can come in here and share some of the stuff.
Well, that would be a great series of shows, Mike, because I would love to get information about that out there.
Yeah.
Thank you, JD.
Yeah.
Well, let's do a quick screen share here.
Awesome job,
night, everybody. Thank you.
And a full house all night too.
Sweet. Yeah, we kept it good, you know. But tonight we got to sit down with the YouTube Model Builders Hangouts and myself, Barry, and Mike Dettinger, the new Model Railroad Tech Show. So everything was, I think we went along pretty good. We got to polish it some, but we will get there.
A+, A+.
Thank you very much, man. Thanks, dude. Let's not forget the YouTube Model Builders, the eMag, the very free eMag that is now going to be coming up on its 3rd edition in the next couple weeks. And we also have our hangout that we do here on Tuesday nights. It will be 2 hangouts a month. Will be hosted by either Dude or Troy. Whatever topic that they have open, they'll have fellow YouTube modelers on there to cover the topic, and they will moderate the hangout for the night. Gino will be having a new show starting in May. It'll be all on structures and weathering. And, the 4th Thursday of every month, Mike and I will be doing the Model Railroad Tech Show. And then on Thursday nights, we have the Model Railroad Hangout with Johnny. So I hope everybody gets a chance to pop in there, and it's a totally Model Railroad focused hangout, and Johnny will whip you to death if you talk of anything else. So. But yes, this is all for us to have fun and enjoy our hobby and share our knowledge and love with everybody else. So I hope everybody enjoyed tonight. And like any ideas, you guys, a lot of you guys have my email. You see us on Hangouts. Let us know what you want to see. This is the beginning of a new series of shows, and hopefully we'll be getting a lot of really interesting topics for you. I know I want to try and get some people on to do more stuff with JMRI, do signaling. I want to maybe get Miles Hale to come in and do some stuff on 3D printing and Cricut Craft Cutter for doing structures and such. So we got a lot of good ideas coming up.
Hey, Barry.
One of the
Yes,
ideas,
sir.
here that came about was on the audio side. Maybe some experts can come in and talk about using baffles and different types of speaker structures and how that works.
Yeah, that's a good point, because we do want to touch more on like sound installation. So that's definitely something that we want to touch base with, is trying to find someone that might be really good with doing speaker design.
Yeah, and maybe we can refine that down the road with the eMag as a whole theme for that magazine.
Oh, sure. Yeah, we can definitely try and work something like that out. We just got to find some people. Yeah. Johnny's already trying to kick us out.
I just want to say, I have to say this, Barry, we've been working together with YouTube Model Builders for some time now, and I can't express the excitement that I have to see you sitting in this chair doing this show, because you're just so fitting for this. You fit this part so well, and with your expertise and stuff, it's just going to be an awesome showing every month, I'm sure.
Oh,
it's just awesome. I'm just so glad to see you sitting here, man.
Me and Mike make heck of a pair. We kind of feed off of each other's wild, crazy ideas, Sit us alone in a room for a few hours.
He's awesome. You guys really work great as a team. There's no question about it.
Yeah, we do. Yeah, we were out over the weekend. We went and visited a gentleman in Lancaster area, a senior citizen who contacted our club, and he's been collecting LGB trains and track for 35 years. And he's 68. He has to take care of his wife who has MS, and he's raising his grandkids. And he wanted to know if we could help him build his layout. So we went out there. It was me, Mike, and our fellow club member Bill knows Jim Langley, and a friend of Jim's came out, and we inventoried all his equipment, measured up his basement, and now we're going to do a track plan for him and start constructing a layout for him. And he's going to provide us all the materials. So we're doing this out of the kindness of our hearts, and because it'd be fun to build a layout. Never did G-scale before, so this will be fun.
So we're virtual pat on the back there, Barry.
So Barry, how many viewers did we have tonight?
Maximum I saw around 18.
Okay.
At the beginning.
Not bad.
We'll work on getting more. So we will definitely try and get this going better. This is our first shot out of the gate, so we've got a lot of stuff we've all learned over the last year, so we will work to apply it to this. So.
Well, I want to thank you all. We have learned a little bit about the LED aspect of wiring up ditch lights and everything. I've switched a couple LED lights in the front. That ain't no biggie. Swap out, put a resistor on it, boom, you're good to go. But, y'all put a lot of information in the brain.
Oh, it's good, Scott. I'm glad we helped you. I mean, me and Mike we're both working computers, and I went to school for electronics, so this is right up our alley. And we both like doing this kind of stuff, so it comes natural to us to think like this, you know.
Well, it's nice to have somebody on the crew that, I mean, like I told everybody I talked to, you know, I says, this is a tight-knit little family of a bunch of experts in every different kind of field that you can imagine on H, O, N, Z, you know.
Yeah.
If anybody needs a question asked, this is the panel to come to, you know what I'm saying?
There's somebody we have somebody that if we don't know it, we know somebody that does know it, you know, which is
Exactly.
a good thing. And
Bill told me.
And I just to say too, just for all of the hangouts that are posted on the Google Plus community, there's several individuals post on the community every week, and there's several different things going that are helpful for people. I think that's it, right?
Hey, Mike.
We're about done.
Go, Mike.
Yeah.
Is it okay to plug my Wednesdays?
Actually, that's kind of what I'm doing, is I'm putting it out there and saying on the Google site that many people post, and of course you post on Wednesdays. Several people even, like Andrew. Andrew posts every day. There's hangouts every day.
Right.
YouTube Model Builders
definitely,
have Tuesdays and Thursdays.
Yeah, just everybody get out to the community. You know, check out all the hangouts that go on. I mean, you'll find a lot of interesting stuff, a lot of interesting people out there, you know.
Well, I have the beginners hangout on Wednesday nights.
Yeah, you worked a lot with Scott, Bill, so I know Scott's really enjoying working with you.
Hey, you see behind me his layout. 18
Hey,
by
looks
18.
like you got a lot of progress, Scott.
It's coming along.
Scott's layout or Bill's layout.
There you go. Hey, Andrew.
Actually, it's Bill's layout in West Virginia, and he's going to fly me down to Florida to do my layout.
There you go. There you go. Well, folks, thank you all for attending. Thank you to everybody who watched and asked, putting questions that we were so gracious to get to answer. So, thank you. We will see you again in a month, and look forward to Gino's show and all the other hangouts coming up. So, just make sure you check on www.youtubemodelbuilders.com for all the event schedules and everything coming up over the summer. So we'll keep you busy and keep the information flowing, all right?
Thanks, Barry.
Good night. All right, thank you, dude. Thanks, Mike. Good night,
Good show, guys.
everybody.